This is a really cool question because it's dealing with rotating parabolas, and the way we're going to do this is by using a matrix. So basically what it's asking is the Cartesian equations of the parabola with focus 2, 2, and directrix is x plus y plus 4 equals 0, which means that the directrix is not horizontal or vertical, which means that the parabola by definition will not be one of these four. It will be a different form, something along the lines of that, with an axis which is not horizontal or vertical. Okay, so let's have a quick look at it. This is for sourcedesmos.com. Thank you to them. So here we have the directrix x plus y plus 4 equals 0, which is the same thing as y equals minus x minus 4. So therefore we know that the gradient of this is minus 1, and so therefore we know that the gradient of any normal to it, and let's just draw this normal here, the gradient of any normal will be a gradient of 1, and that means that it will go through here 0, 0, and it also goes through the focus, which we are told was 2, 2. So therefore clearly what we have here is a parabola where the axis is the line y equals x, that's the axis of symmetry, and clearly this whole thing has been rotated around 45 degrees from a parabola which would have looked like that. So what we need to do is we need to look at the original parabola and then rotate it using a matrix. Now first of all, let's just have a quick look at this here so we can find the focus and the A part of the parabola. So this here is 2 and this here is 2, which means that that distance there, the distance from the vertex to the focus, is going to be the square root of 2 squared add 2 squared, which equals 2 root 2. So therefore we know that the distance from the focus to the vertex of this parabola is 2 root 2, which also means incidentally that that is 2 root 2, the distance from the vertex to the directrix. So let's have a look at the unrotated parabola now, which is this one. Okay, so if we look at the unrotated parabola, here is 0, 0. Well, this now is the directrix x equals minus 2 root 2. It is now a vertical line because we know the distance between the directrix and the focus is 2 root 2. And we know that the focus here is going to be the point 2 root 2, 0. That's the focus because we know that that distance is 2 root 2. Okay, now also we know on this parabola here that a general point in parametric terms is at squared 2at, and we have already worked out that a, which is the distance from the focus to the vertex, is 2 root 2, so therefore we know the general point here is 2 root 2 t squared 4 root 2 t. Okay, now what we have to do is we need to rotate it. So let's just have a quick look at a rotation matrix. So the rotation matrix by theta degrees anti-clockwise, the rotation matrix we have to apply is cos theta minus sine theta, cos theta. So for an anti-clockwise move by pi over 4 or 45 degrees, it would be cos of pi over 4 minus sine of pi over 4, sine of pi over 4 and cos of pi over 4, which equals 1 over root 2 minus 1 over root 2, 1 over root 2, 1 over root 2. So we need to apply this rotation matrix here to the coordinates of this parabola, and these are the coordinates in parametric form. Okay, so let's do that. So we have 1 over root 2 minus 1 over root 2, 1 over root 2, 1 over root 2, times by, or in the matrix, 2 root 2 t squared, 4 root 2 t, and then when we multiply that, we get 2t squared minus 4t, 2t squared add 4t. And if you don't know how to multiply a matrix by coordinates, then maybe go and have a look at our Gresti Academy video on that. Okay, so now we have the coordinates of the rotated parabola are x equals 2t squared minus 4t and y equals 2t squared add 4t, and we have to get the Cartesian coordinates of that. So what we can do is we can add them together, and that gives us x plus y equals 4t squared, and then we can take them away from each other. Y minus x equals 8t. Okay, and then what we can do here, that implies this one is that t squared equals x plus y over 4. And from this one, we get that t equals y minus x over 8. And so therefore, t squared is y minus x squared over 64. And then we can equate the two t squareds, which gives us our Cartesian coordinate of x plus y over 4 equals y minus x squared over 64. Or tidying that up very slightly, 16x plus y equals y minus x squared. And that is the Cartesian equation of this rotated parabola here. Okay, so we found the answer, but just to confirm, what we could also do is we could put this directrix through our rotation matrix just to confirm that it does actually produce that directrix, and we could also put this focus through our rotation matrix to confirm that it does actually produce that focus. Okay, so let's just do that as a little bit of an exercise. So we got our rotation matrix is 1 over root 2, 1 over root 2, minus 1 over root 2, 1 over root 2. Okay, and let's first of all put the focus through it. So 2 root 2, 0 is the focus of this one, which is the non-rotated matrix, and that should come to 2, 2. So let's have a look. If we do that, we get basically 2 root 2 over 2, 2 root 2 over root 2, and 2 root 2 over root 2, which equals 2, 2. So indeed, 2 root 2, 0 does get mapped to 2, 2 under the rotation. And let's just have a look at the directrix. Well, the directrix was x equals minus 2 root 2, so that would have parametric coordinates of x equals minus 2 root 2 and y equals t for any t. So let's put that through. 1 over root 2, 1 over root 2 minus 1 over root 2, 1 over root 2. Let's put this through. 2 root 2 minus 2 root 2 t. That would give us minus 2 minus t over root 2 minus 2 add t over root 2 for any t. So therefore, the parametric equation of the rotated directrix is x equals minus 2 minus t over root 2 and y equals minus 2 add t over root 2. Of course, you don't need to do this. We've already answered the question. This is just a check for those who are interested in this. And then if we add those two together, we will get x plus y equals minus 4, or x plus y plus 4 equals 0, which was the equation right up here of our rotated directrix. Okay, well, I hope you found this useful. If you have, please subscribe to the Agresty Academy YouTube channel and like this video by pressing the little thumbs up button. Thank you.